I'm going to show you a little bit about what's called rotational inertia in physics and some games you can play, rolling things down an inclined plane. And it has some surprises. So one way to think about rotational inertia, I've got like a yardstick, and if I hold it in the middle, you think about like how hard my fingers have to push to hold it, and compare that to how hard my fingers have to push if I'm going to hold it from the end. And you can tell that that feels very different. Not so much force that I need to apply there, quite a bit more there. And you can imagine if this was even longer than a yard, it would be even harder. And that is because even though the mass of the stick is the same, the weight is the same, its rotational inertia is going to change depending upon where I'm applying that force at. And when I'm applying a force at the very, very end of the stick, I have as much of the stick as far away from that rotation axis where my fingers are as there can be, okay? Rotational inertia comes up when things are rolling. I've got like a couple cans here, soda pop cans. So one is empty and one is full. For the empty can, it actually has most of its mass as far away from the rotation axis as it can be. But for a full can, it actually has a lot of its mass right along the rotation axis, right through the middle of the can. And what we're going to see is the way that matter is distributed, this one with more rotational inertia is going to take longer to roll down the inclined plane. And it turns out that actually the mass of the object doesn't matter because it's the force of gravity that's pulling it down the inclined plane. And actually the radius doesn't matter either. So you can play all sorts of games of like racing hollow balls versus solid balls, or quarters versus hula hoops, things that are solid versus things that are empty on the inside. And what you're going to find is the more rotational inertia it has, the more of its mass is further away from the rotation axis, the slower it has to go. Alright, so let's just try out these two first. So the full can versus the empty can of soda. 3, 2, 1. Empty can with a greater rotational inertia was always moving slower at the same time than the full can. And then some fun things, you can actually roll some things where the rotational inertia changes. So I've got a little jar of honey, and when it rolls, you see it's going to roll in fits and starts because the viscous honey inside is readjusting itself the whole time. If it were full, it would roll smoothly, but since it's not full, it's going to go in starts and stops. It'll roll for a little bit and then the fluid's in the wrong place. Gravity doesn't make it roll anymore, so it'll stop, and then the fluid is going to flatten out again and then it can roll again. So you get some fun looking things for these sorts of objects that have a changing rotational inertia. So those are some games you can try out with rotational inertia.